Alright, hello guys. Today we're going to take a look at my Arduino project called the Monophonic Tune Player. Um, as you can see, it uses the Arduino Uno breadboard, two push button switches, one piezo element, one LED, you can choose whatever color you like, two 560 ohm resistors, one 10K ohm resistor, and I use 9 jumper wires. You may get some other number depending on how you decide to set your board up. So yeah, as you can see, let's take a closer look at what we'll actually be building. Okay, so this is the prototype. This, as you can see, there's two push button switches. This one right here is for playing the song that you select, and this one right here, it will cycle through the selections each time you push it. Pretty cut and dry. So you would select your song and then play it. When the song is playing, the light will come on. When the song is done playing, the light will switch off. Another part of this is that we're communicating with the serial output here, so when you hit the switch, it will tell you that it is playing the song, and when you're selecting the switch with the selector button, it will tell you which song you've selected. As a side note, after the song is finished playing, it will tell you how many notes were in the song, and I just thought that that was some good information to display. So that is essentially the functionality of this monophonic tone player. Let's go ahead and take a look at the code, shall we? Alright. This is the pitches file. This is so this, you can find the code for something that's like this on the Arduino site. I went and tuned it to this solfeggio scale, which is a 342 hertz for the fourth octave of A. So these are the notes that will be being played by all of the songs that we're using. I've also got pitches tuned to 440 hertz in the library files, so if you wanted to update that, you would just come over here into our header file for the piezo music, and you would change this right here if you wanted to use the 440 library, because if you're an audiophile, perhaps you think that that's just the bee's knees or something. You would just update your library like that. I like the solfeggios, so I'm going to stick with that. As you can see, just our typical header file. Here's our class name, our public methods. This is a constructor, a destructor. This is we'll be looking through the code in just a moment. This is just a header file, but this will be the function that plays the songs. This is the function that will ring the piezo, and this function is not actually effectively working yet, but it will. I will use that to break into the play loop to stop the song from playing. It's not working yet. Okay, I'm sure that you guys have all seen some of this code before. If you while doing your examples, the piezo examples at the ADRX or ARDX labs or whatever. And basically that's just this simple functionality. I pulled it out of there, put it into this this method over here called play tune, where I can then give it whichever song I want it to have, and I can also change the tempo, so I can increase or decrease it. The bigger that gets, the longer the delay. The smaller that gets, the shorter the delay between the notes. Here's the buzz function. Once again, this is something that we've seen before, this aspect of it. I just pulled it out, turned it, made it more abstract to where I can update this information easily. and change it throughout the code. And here's that function that's not really doing anything yet. Alright, let's go take a peek over here and at our demo. Wait, do I have that right? Yep, no, we're going to look at the INO. Okay, so this is our actual control code. We set a pin for the play button. We set a pin number for the selector button. We set a pin number for the LED, and we set a pin number for the piezo. We're going to call our play button number 1 and our selector button number 2, and you'll see these being used later on down here with our state change function. These variables here are being used to track the state of the buttons. If it's pushed, each time it's pushed, this will be incremented. This is the state, it's either on or off. And this is the last button state, so we can compare it as we go. And this is just the other button, same situation. Here we are initializing our piezo music player class. This is the variable, this is the type of piezo music. Next we'll define the songs, and I made one array called song names so that I can output these easily. And the name matches the order of the order of which I'm going to load these. If you'll see, like song name 0 is Mario Brothers theme, well song name 0 is Mario Brothers theme. Song name 1 is Mario Brothers World. So as you can see, my note and tempo arrays match the song name arrays. So this will be 1, this will be 2. If I was going to go and change that, that happens down here in the, wait, that's not it. Oh, here it is, in this switch right here in the play function. Okay, now for some helper functions to be able to, now you created these to help me control the program flow while using the library. This function doesn't use the library, it's just checking the state, and I'm using those state variables and the identifier. So if the play button has had a state change, return if it's equal or not to the last one. If we're trying to get the state of some component that doesn't exist here, it will just spit out a message to the serial. Here is playing. We're going to check the push counter for whichever button we're doing. In this case, is it playing? That only counts with the play button, right? Because although that may change in the future, because if we're playing and I want to change the song, that would be good to do. But as for now, I increase the counter and then I return whether or not it is on or off. And I don't know if you guys have seen this before, but if not, this is a modulo symbol right here. So I'm taking the remainder of however many times I push the button divided by 2. It'll either be a 1 or a 0 being on or off. So if it's divisible by 2 and I get a remainder of 0, that means that it is off. If there's a remainder of 1, then it's true. There will only ever be a remainder of 1 because we're dividing by 2 here. You'll see down here in this next function, the get the song index, I'm using the same idea here. I'm taking the modulo, or the modulus of this push button counter for the select button push counter. And what that's going to do is, whatever number, however many times we push that button, we'll divide it by 4, and then our remainder values will only ever be one of those values. It will either be 0, 1, 2, or 3. Which 0, 1, 2, and 3, if you'll notice, they correspond with our songs, right? Here's song 0, here's song 1, here's song 2, here's song 3. Alright, and then I wrote this play function, and this function here, this is just a wrapper for our Piezo music player class, and here we're actually going to do here we're actually going to play the songs. And one of the issues I was having with stopping it from playing in the middle of a song is the fact that I'm calling this function, which then goes out to a library outside of the for loop. So I need to break out of that and then also notify this. I just haven't got to it yet. But anyways, back to that. So when I run this play song, or this play function, I'm going to pass it an index. Which song do I want to play? 0, 1, 2, or 3? One of my 4 songs. As I add songs, I will, or what I mean to say is that once I add songs to this, I'll update this. So if I added another song, I would change this to 5, and then I would just add another case here. Case number 4, and that will then just check for another song. I also want to make sure that I add the name to the song's name array, which you can see here is where we're printing it out, the song name, song index. So we hit the play button, we're going to say that we are playing this song, whichever song is at this index. And then we're going to pass the song index in, and that will be this value. Whichever one of these it is, it will play the appropriate song using the library code that we just looked through. If we try to pass if we try to play a song that doesn't exist, we're going to say, wait, something's wrong here. I could be more specific, but it's pretty unlikely that it's going to happen since I'm doing it myself and it's not automated. Yep, so while the song is playing, the LED is on, and due to the way the program is, the control of the program is written, that's happening down here, so you're going to see it get turned off first here. But after the song is done playing, we'll turn off the LED, and then we'll print out to the serial, finished playing, however many notes. Now for the main function. Here we're just going to set up our pins and start our serial output and input, our serial communication. So input for the buttons, output for the LED, and output for the Piezo. Pretty obvious. And now for the main control flow of this program. So basically what happens is every time we run through the loop, we are going to read our button states, or our button pins, and set the state. Is the button pushed, or is the button not being pushed? Right? So we're going to read whatever that is and check it here in state change. Right? We're going to pass in and we're going to say, is the selector button pushed? If the selector button has changed, then we're going to see, is it high? If it's high, meaning it's been pushed down, then increment the counter and load this song. And at this point, the song isn't really being loaded. What's happening is that I'm just letting you know, and you'll see over here when we demo this in this serial output, it will tell us the song has been loaded. So you load the song and it's been loaded. And then we will reset the selector last button state with this current state for the next time we go through the loop. And then we'll do pretty much the exact same thing here, but we're checking the play button. And if it is high, if it is on, then we will write to high to the LED pin, turning it on. And then we will play our song using our method, our helper function play that calls the class Piezo music play tune. So this was just our wrapper function here in the INO file. Alright, so that's just a very high level quick walkthrough of what we're looking at there. Now let's go ahead and do a little demo and see how this works. To do that, we want to open up our serial communication so that we can see if this is working or not. Let's load a song. Mario Brothers Underworld. As you can see, the light's on while it's playing. I used the selector to pick the song and the play button to play it. The song's over, it turned off. Back over here, we can see that we loaded Mario Brothers Underworld it played it, and then when it was done, it told us that it played 56 notes. Let's play another song, and if you guys just want to watch over here and then see how it communicates with my computer, let's do that one. Alright. Well, guys, that is the Monophonic tune player. We'll just, if you just look at this real quick, you can see how I've got it hooked up. Any questions, you guys feel free to hit me up. Thank you.